I have a bit of an extended introduction this evening. I'm going to say a brief word about BCRW events and acknowledge the work of people who have made this event possible. And because this event is graciously co-sponsored by the Pembroke Center for Teaching and Research on Women at Brown University, we have the director of that center here who's going to say a word as well. This is Suzanne Stewart-Steinberg. And then after Suzanne speaks, I'll introduce our speaker, Tina Neal. As always, I want to thank the many people whose labor makes our events possible, all of the staff at BCRW, in particular, Administrator Pam Phillips and Post-Baccalaureate Fellow Eve Kausch, as well as our student research assistants who are here tonight, Emily Reed and Sophie Kreitzberg, back in the back with the fabulous Dare to Use the F Word t-shirts. Get yours. I also want to thank, there's snapping happening here. I also want to thank the Events Management Office, the Office of Public Safety, the IMATS technical staff, and Jason, who's in the back helping us out with this, the videographer, who's also preserving this for posterity, the caterers. We have a lovely reception afterwards, so stay for that, and especially the facility staff at Barnard who make the spaces that we use for our events so hospitable. So let me now invite Suzanne Stewart-Steinberg to the podium to say a word of greeting from the Pembroke Center, and then I will introduce Tina.
Good evening, everyone. Thank you, Elizabeth. So as Elizabeth mentioned, my name is Suzanne Stewart-Steinberg. I'm director of the Pembroke Center for Teaching and Research on Women at Brown University. I also happen to be professor of comparative literature and Italian studies there. So the Pembroke Center was very delighted when Elizabeth Castelli and Leora Tannenbaum, who's sitting here in the front, invited the Pembroke Center to co-sponsor tonight's program. Elizabeth and Leora are Brown graduates and longtime volunteer board members and supporters of the Pembroke Center. I'd like to thank them for bringing Barnard and Brown together this evening and bringing us into conversation with Tina Neal, who is another distinguished Brown alum. The Pembroke Center has been at the forefront of efforts at Brown to study the politics of gender and sexuality through a wide variety of disciplinary lenses and approaches. Our research and teaching explores social change and how questions of difference, such as gender, race, class, and/or religion, affect our thinking and our world. Our center is home to the program in gender and sexuality studies, as well as of the archives that preserve the history of Brown and Rhode Island women and the intellectual history of feminist scholars. And I may want to just point out that Ryan, sitting in the back, is a graduate of our program, Gender and Sexuality Studies. The Pembroke Center organizes programs such as this one to connect alumni or alumnae with each other and also with our work. So thank you very much for coming tonight, and thank you especially, Tina, for sharing your exciting work with us. Thanks.
Okay, we're almost there. I am so thrilled to have the opportunity to introduce this evening's speaker to you. Tina Neal is the scientist in charge of the Hawaiian Volcano Observatory, where she has held this post since 2015. Her list of accomplishments is lengthy and detailed, so I'm just going to offer a few highlights. Educated in geological sciences at Brown University, Arizona State University, and UC Santa Barbara, Tina has always been interested in volcanoes. Indeed, while still an undergraduate, she was a NASA intern at the USGS in Flagstaff, Arizona, investigating volcanoes on Mars. For most of the 1980s, she worked for the USGS at the Hawaiian Volcano Observatory, tracking eruptions of Kilauea and Mauna Loa, and also mapping portions of the rift zone and summit areas of Kilauea on the Big Island. But not satisfied merely with Mars and Hawaii, she also participated in an expedition to study the rift system on the ocean floor north of the Galapagos Islands. In 1990, she moved to Anchorage to the newly established USGS Alaska Volcano Observatory, studying a series of eruptions there over the ensuing years. In 1998, she accepted a temporary position as USGS Geoscience Advisor to the Office of the U.S. Foreign Disaster Assistance of the U.S. Agency of International Development in Washington, D.C., where she oversaw and initiated programs in geohazards mitigation, advised the Office on responses to geologic disasters, served as a liaison to other federal agencies, academics, and NGOs, and helped develop a global strategy to deal with natural hazards. During this time, she worked around the globe from Thailand and Nepal to Ecuador and Colombia to Kazakhstan and beyond. She returned to Alaska in 2000 to resume her duties as staff geologist at the Alaska Volcano Observatory, working on geologic mapping, eruption response, and physical volcanology studies of active volcanoes in Alaska, as well as pursuing a range of increasingly complex and challenging projects. Since 2015, she has served as the scientist in charge of the Hawaiian Volcano Observatory, in addition to leading the observatory during the 2018 eruption and summit collapse crisis. She's focused on workforce development and preparing for the next Mauna Loa eruption. Tina is going to draw on her compelling career and her experience around the globe to focus this evening on a recent dramatic eruption at one of the world's most active volcanoes, Kilauea in Hawaii, in 2018. In addition to teaching us about the science behind this extraordinary event, she will also share her insights into the complex world of incident response and help us deepen our understanding of this remarkable part of the natural world. It's a true pleasure to be able to introduce such an accomplished scientist to you this evening. So please join me in welcoming Tina Neal to Barnard.
Thank you so very much, Elizabeth, and thank you to Barnard and to the Pembroke Center at Brown for sponsoring this event. It's a true honor to be here as part of this lecture series. It's always amazing to hear your life recounted in front of you. I guess a lot of time has passed. As Elizabeth said, what I'd like to do tonight is give you a sense of some of the excitement that happened last summer in Hawaii, on the Big Island of Hawaii. Before I get started, how many of you have been to the Big Island and seen the volcanoes there? A good number. Okay. Well, I hope this is familiar ground to many of you. And for those of you who haven't been there, it's worth a visit. So I will talk about what happened last summer at this remarkable volcano. Truly kind of a capstone eruption experience for my career. And hopefully give you a glimpse into some of the human impacts of this eruption, some of the science that went on, and that interplay of science and public policy and safety that is really the work of the U.S. Geological Survey, which is the federal agency for which I work. The U.S. Geological Survey sponsors the Hawaiian Volcano Observatory. So we'll jump right in, and I would like to start with some geography to get us all acquainted. This is an image of the Big Island of Hawaii, the southernmost and youngest of the Hawaiian Islands, showing 4 of the 5 volcanoes that make up the island: Mauna Kea to the north, Hualalai on the west, the large volcano Mauna Loa, and the youngest volcano on the island, Kīlauea, which, as commonly said, is one of the world's most active and most well-monitored volcanoes on the planet. It has long been recognized it's a great place to study volcanoes because it's so frequently active and also very accessible. It's essentially a drive-to volcano. And of course, Hawaii sits here in the middle of the Pacific on one of the most isolated land masses in the world, a hotspot volcano fed by magma from deep within the earth that rises to feed this chain of volcanoes marching across the Pacific Islands, Pacific floor. Some more geography. Zooming in on Kīlauea Volcano, we're going to be talking about activity at the summit of the volcano, here where there's a large crater called a caldera at 4,000 feet at the summit of the volcano. The other action from last summer occurred along the east drift zone of the volcano. This linear ridge that extends off into the ocean here is a long chain of cracks and fissures, a place where the volcano frequently erupts. There's also a southwest drift zone that heads in this direction. So the 2 other areas I'll be talking about are the Pu'u'o'o vent here on the middle east drift zone, a place of eruption since 1983. It has repaved much of the south coast of the volcano. And then the lower east drift zone, abbreviated LERZ, which is where last summer's large eruption of lava occurred. Just for human context, in the summit of the volcano, there are about 3,000 people that live within about 6 miles of the summit caldera. This is including the Hawaii Volcanoes National Park, which many of you have probably visited, the Volcano House, and where Gail and I were living at the start of last summer. There are about 40,000 people that live in a mostly rural area in the lower East Rift Zone region, including right along the Rift Zone axis, which is a known place of frequent eruption. And then about 40,000 people in the adjacent city of Hilo, the main urban center on the east side of the Big Island. If we look at the volcano in cross-section, this sets the stage for what we'll be talking about and what happened last summer. So here is the summit of Kīlauea Volcano with a crater at the top at 4,000 feet. And until May of last year, there was a lake of lava active at the summit of the volcano, sitting on top of a shallow magma reservoir about a mile and a half below the ground that was fed by magma coming up from the mantle of the earth at a fairly continuous rate. And for 35 years, magma was entering this magma reservoir and feeding the East Rift Zone eruption at the Pu'uo'o vent about 12 miles away, which was intermittently sending lava flows to the ocean, but mostly contained within the national park and not really bothering too many people. There was a period of time when the lava flows were heading outside the park, and they covered about 200 homes over the course of 35 years, but largely activity was confined to the park. And just to skip ahead, what happened last summer is that connection to the Pu'uo'o vent in the Middle East Rift Zone was broken, and instead a new connection was established, feeding an eruption 12 miles further down the Rift Zone in the Lower East Rift Zone at the Leilani subdivision, which produced the very dramatic lava flows that you saw in the news last summer. So this was the big shift that happened in 2018, and at the same time that magma was pouring out of the ground at the eruption site, the lava was draining away from the summit, causing the roof of the volcano to collapse inward, and I'll demonstrate that to you in some images coming forward. So this all began really in about March of 2018, when geologists watching the volcanic eruption on the Middle East Rift Zone saw that some change was happening. Basically, our global positioning system instruments out on the Pu'uo'o vent, shown in this picture, measured between two benchmarks about a mile apart, were starting to show that this part of the volcano was swelling greatly. The level of lava was rising high inside this cone, and the ground was expanding. It was becoming pressurized. So we knew that something was changing in the system. Essentially, magma was backing up. And this data, this change is shown in this plot here. This is the GPS line length from benchmarks across the cone, showing pretty steady conditions for a couple of months in the beginning of 2018, and then a very steady and rapid rise into March, which looked to me like an accelerating rate of change. So we issued a public statement in mid-April that said, it looks to us like a new vent may be getting ready to break out somewhere on the volcano because the system is becoming pressurized. At the same time, the lava lake at the summit of the volcano was rising and overflowing onto the caldera floor. So the entire system was becoming pressurized and engorged with magma. On April 30th is when things really began to happen. The Pu'uo'o vent that we were just looking at actually went through a dramatic collapse. It went from looking something like this, with a lava pond about 500 yards across, to a very deep crater when the lava drained within and below this cone back into the core of the rift zone, basically withdrawing support for the roof of the cone, and it collapsed. At the same time, our GPS benchmark saw that collapse, and the line length contracted greatly and continued to contract into the following weeks as the cone was falling in on itself. So at this point in time, magma was draining from the surface area of the Pu'uo'o vent back into the rift zone core, and we were beginning to see earthquakes propagating down rift. So here's the collapsed Pu'uo'o cone on the Middle East Rift Zone, and in cross-section we were seeing evidence of withdrawal of magma into the rift zone core, and then moving further to the east, about a mile and a half below the ground, towards the lower East Rift Zone. This motion was dramatically shown by a migration of earthquake epicenters that we could detect with our instruments, marching down the rift zone. In addition, the GPS instruments along that track were showing the ground bulging as magma was running down that core of the rift zone. So it was very clear what was happening. We were having an intrusion of melt into the lower East Rift Zone. And in this map view, here's the location of the Pu'uo'o vent that collapsed. This was the region of earthquakes outlined in this red dashed line. So we issued a statement in May, on the 1st of May, a public statement saying that this region was likely to see an outbreak of lava, and unfortunately it coincided with a subdivision, the Leilani Estates area, and so civil defense got busy going door to door to let people know that they may have not much time to evacuate. Now imagine you get a knock on the door saying you need to think about evacuating. What would you do? It's a good mental exercise actually to go through. In the subdivision, starting on May 1st, the signs of this intrusion of magma as it was moving underground and then shallowing towards the surface, we started seeing these tremendous cracks underneath the roads. You can see a person here for scale. In addition, there were areas that were heating up and hot steam and gases were pouring out of the ground. The residents were feeling earthquakes and tremors as the ground was responding to the forceful intrusion of magma towards the surface, so it was a very dramatic change. This convinced a lot of people to leave, but not everybody. And then 2 days later, after the first public warning, magma broke the ground in the Lower East Rift Zone right within the Leilani Estates subdivision. And this is a photograph that we took from the helicopter showing magma, lava at this point, bursting out of the ground right in people's backyards, cutting the roads along a several-mile swath of terrain. So at this point, things are serious, and people are leaving, and civil defense is busy trying to figure out who is where and who needs to be evacuated. As if that weren't enough, on the next day, on May 4th, we had the largest earthquake in Hawaii since 1975. It was a magnitude 6.9 event, which is a very large earthquake, and it occurred just off the south coast of the island. So back to the map view, here's the eruption happening. Here's the summit of the volcano, where the Hawaiian Volcano Observatory is. Here was the epicenter for this 6.9 earthquake. So this earthquake occurred at the base of the volcano, near where it sits on the old ocean floor. And during this earthquake, the whole south flank of the volcano moved about 70 centimeters, a little more than a yard, towards the south. Likely, this was caused by the pressure of the magma moving through the rift zone, pushing that south flank away. It finally just failed and moved. But that's a lot of motion and a lot of ground shaking. There was damage. It was certainly a scary event. I actually missed it. I was in a helicopter at the moment, which as a geologist was a real disappointment. But I'm certain it would have been frightening, so I'm glad I missed it. The earthquake seemed to have very little effect on the eruption in the Lower East Rift Zone. Lava continued to come out along a series of fissure vents in the subdivision. And that activity continued for the next 3 weeks. So between May 3rd and May 27th or so, there were 24 separate cracks that opened up along a line, and lava was spurting out of these cracks. In this picture, we see along the line here, we see some of the lava pouring out of the ground and feeding a river of molten material moving away. And as you can see, just coursing through the subdivision, pouring through people's homes and in their backyards. There were a few pauses during that time where there were stops and everything went quiet. And then we'd see earthquake activity pick up again and a new crack would open. And in fact, there was a time when the earthquakes continued to propagate further east, and we were able to see that because of our sensors and issue another warning to the people further east that something was coming. So those early fissures and flows in May tended to produce kind of short bursts of lava, not very high into the sky, sticky, viscous flows that moved along the roadway here. This was a typical flow moving pretty slowly. Easily you could outrun this. You can see this awful smoke that develops where the 2,000 degree Fahrenheit lava is burning the asphalt below. But even though these lava flows were short, they did a lot of destruction in those first 3 weeks. Interestingly, in the first 3 weeks, the magma that was being erupted was of a lower temperature and a chemical composition that was quite a bit cooler and different than the lava we'd been seeing in earlier eruptions. And we think this was happening because as the molten material moving in the rift zone from the 2018 event was coming to the surface, it actually ran into pools and pods of older lava, some from the 1955 eruption in the area, and essentially goosed this older, colder material to the surface first before the hotter, more fluid material came to the surface later. So that was a very interesting phenomenon to see demonstrated. But by the middle and end of May, we had flushed out the system of all that older, colder magma, and we started to see the hotter, fresher material from the Summit Magma Reservoir. Those lava flows came out more quickly, at a higher rate, and they fed lava flows that reached the ocean by the late part of May. Here are some amazing aerial photographs of those lava rivers, including this one here, where it's actually reaching the Pacific Ocean about 4 miles downstream from the vent. And some more pictures of lava just coursing through subdivisions and agricultural fields. On May 27th, activity died off at many of those cracks, and they localized down to a single point, which became known as Fischer VIII. You may have heard about Fischer VIII in the news. Fischer VIII became the sole locus of activity for the remaining several months of the eruption. And at that fissure, the lava fountains built this cone that was several hundred feet high, and fed a lava river pouring out of the cone and heading first to the northeast and then to the south towards the ocean. At this point in the eruption, we had so much lava coming out of the ground at one time. There was also a tremendous amount of sulfur dioxide gas being produced. So as Hawaiian lava reaches the surface, it has a huge amount of gas dissolved within it. And as it gets to low pressure at the atmosphere, the gas comes out in bubbles. Sulfur dioxide is the main one that we measure and watch because it tells us something about how much magma is below ground and where it's coming from. Prior to the 2018 activity, we were measuring about 5,000 tons per day sulfur dioxide coming out of the volcano, and that was enough to create a bad pollution problem in parts of the island. During the eruption, we were producing as much as 50 or even 100,000 tons a day of sulfur dioxide, which created terrible air quality conditions along the southern part of the island and even all the way around the west, where it wrapped around the island into Kona. The VOG, as volcanic air pollution is called, was even detected 6,000 kilometers away in Guam. So it was a very big pollution cloud and was a problem, a health problem for a lot of people on the island. So while all of this action is going on the Lower East Rift Zone, meanwhile, we've got activity back at the summit of the volcano, 3,000 feet higher and 25 miles away. I mentioned that at the summit there was a lava lake that had been there for about 10 years. Well, when the eruption started in the Lower East Rift Zone, that lava lake basically began to drain away back into the volcano. It's just like pulling a bathtub plug down on the Lower East Rift Zone. All of the lava that was coming out to feed the eruption was taking place of the lava that had been at the summit. And so the lava lake began to drain deep into the volcano. And I should point out that this was a time when my sister Judy from Manhattan was visiting and got to witness some of this draining of the lava lake. The lake began to drop more quickly after the earthquake on May 4th. It dropped about 7 feet an hour, and our cameras perched on the rim of the lake caught that draining, which you just saw in that little video clip. And in cross-section and cartoon, again, here is what was happening. Lava was pouring out of the ground to feed the eruption in the Lower East Rift Zone and draining the lake back into the core of the volcano, where it took a right-hand turn down the rift zone to feed the eruption. Basically, the outflow could not be kept up in terms of rate by the inflow from the deep mantle source. So we were having a net loss of lava from the summit of the volcano. This posed a bit of a concern to us because as the lava lake was draining back into the volcano, the level of the lava lake was moving closer and closer to the water table. So even though it's a hot volcano, there's water within the volcano. And we knew from a research drill hole that the water table was at about 600 meters elevation below the surface. And we could project when the lava lake was going to intersect that elevation below the summit of the volcano. And why was that a concern? Well, the last time we had this event in 1924, there had been explosions. And the reason there had been explosions is that when the lava dropped below the water table, the heat buffer that was keeping the water table away from the hot core of the volcano would be diminished, allowing water to seep back into the core of the volcano where it might interact with the hot rocks, producing very large steam explosions. And indeed, here's a photograph from that happening in 1924. So this is a picture actually taken from the site of the Hawaiian Volcano Observatory in 1924, showing one of these very large explosions that we were then concerned about. These explosions threw out very large blocks of rock. Here you see people standing next to one of these things that got hurled a little more than half a mile away. Ash from these explosions fell over several tens of miles from the summit of the volcano, and gravel-sized rocks were thrown more than a mile away. They would have been reaching the volcano house for those of you who'd been there. So this was a concern because the park, of course, is a place for visitors, and by this time the park had decided to close, and HVO soon decided to abandon its post at the summit of the volcano because of this potential for explosions and the earthquakes that accompanied that. Big explosions did begin to happen at the summit. Here was one on May 15th, taken from my office window. A dramatic sight. Luckily, the winds were blowing away. In this picture, the ash cloud is only rising a few thousand feet above the ground. These are explosions, again, through blocks out of the summit crater. Here's some pictures. These are up to about 20, 25 centimeters across, so a couple feet across, and a fairly healthy ashfall in the region. And then on May 27th, we had the largest explosion of the series where ash was sent to 30,000 feet above the ground, high enough to be of concern to jets if there had been jets flying over the island. This actually did interfere with the telescopes on Mauna Kea because the winds were from the south at that time, so the ash and the gas cloud went to the north and impacted the telescopes. They're not used to dirty air up at 10,000 feet in Hawaii. So what was going on? Well, some of these explosions were produced as the lava lake was receding and the walls of the crater were falling in and impacting the lava lake, causing basically rapid vesiculation and bubble explosion, and up would come ash and debris. But as time went on, these explosions were caused by the top of the volcano actually beginning to collapse inward. And that's just because we were losing support for the roof of the volcano. Remember, in that cross-section, we're draining away the magma from the summit reservoir, taking away support from the roof, and it's basically beginning to fall in. It began to fall in a series of steps, pretty regular steps. And here's a cartoon to illustrate that process. So here in cross-section is the summit of the volcano, the big crater at the top. Here's the magma chamber as a cartoon, and a little exit point here showing magma draining to feed that eruption 25 miles away. During times when the magma was draining happily, the roof of the volcano was fine until it started to feel the empty space or the void space that was accumulating or developing in the space where magma used to be. And at that time, we would start to get an increasing number of earthquakes in the summit area as the whole fault system at the summit was starting to strain. And those earthquakes could be very big. They were up to magnitude 4s, 4.5s, and these were the earthquakes that were starting to damage and break the Hawaiian Volcano Observatory building and other buildings in the park. And then finally, the roof would give away and fall in, and we'd have a magnitude 5, 5.5 earthquake, and the ground would drop many tens of feet, sometimes 30 or 40 feet, as the piston at the top of the volcano was basically falling to fill the void space created by the exiting magma. This process repeated itself 62 times from May to the early part of August, and each time that collapse produced a 5.3 magnitude equivalent earthquake in the summit area. So it did a lot of damage and was difficult for people living nearby. This graph illustrates the periodicity of this process. Down here, this is earthquakes per hour from early June to kind of middle of June, showing the increase in earthquakes that would happen over about a 24 to 30 hour period, up to 30, 40 earthquakes an hour, until the roof gave way, you'd have a big earthquake, and then it would be quiet for a few hours again, and then start to build to the next cycle. So this was repeated 62 times over the course of the summer. These collapse events were very dramatic to see, and we did have geologists stationed there watching this event from a safe distance. And so this was the event actually happening, and the block of rock about a mile across would drop, and of course rock falls would occur all along the margin of that piston collapse, producing these big dust clouds. It would create a roar, kind of like the ocean roaring, and the trees would be swaying during the earthquake shaking. It was a very dramatic event. It would be over in a matter of seconds. Here's some pictures showing you what it looked like before and after this collapse period over the course of the summer. This is a picture taken before the eruption began, showing at that time the collapse crater at the summit, which is a little more than a half a mile across. And here's that same feature in August after it had been much enlarged, both vertically and horizontally. So a pretty dramatic change in the summit. Here's another oblique view of the before. For those of you who've been there, here's the Hawaiian Volcano Observatory. Here's the road that used to drive around the crater, the parking lot, the before picture, and the after picture. A very dramatic landscape change. And here, this is a short film that animates that collapse from June to August. This is a sequence of structure for motion, digital elevation models, and LiDAR maps showing the topography change during the course of that. Let's see if I can play it again. Showing the successive collapses, taking more and more of the caldera floor as the area of collapse widened through time. And of course, a big question was, how wide and how big is this collapse going to be? And the unfortunate answer was, we didn't know. So this was one of the big challenges for me as the director and the volcanologist in charge there, trying to talk to the public in the park about how big and how bad is this collapse going to get. We didn't know if eventually this whole floor of the caldera was going to collapse, including taking maybe the volcano house with it. In addition, there was a period of time, several periods of time in recent Kilauea past where large explosive activity became common at the summit. And this activity of collapse could have been leading us in that direction. We just didn't know. So for me, it was a very difficult challenge to try to tell people what we knew, what we didn't know, and to give them some bounds on that uncertainty so they could make some decisions about whether to stay or go and that sort of thing. Okay, here's another short animation of this process. This is a time lapse of a camera that was on the roof of HVO looking down at the collapse crater during this whole summer event. And you'll see a series of explosions and then the floor just dramatically begin to drop away. So in places, these new walls that formed are 200 to 400 feet high. An incredible new landscape that formed in just 3 months. We'll watch it one more time. The early part of the eruption with lava still showing, and then ash explosions as the collapses begin. And then watch the walls begin to steepen and grow over here in the far field. So each one of those 62 collapse events dropped at another 20 or 30 feet. How far did it fall? These are some cross sections to give you a sense of that. The blue lines are the pre-eruption cross section of the summit of the volcano, and the red shows the aftermath. And how convenient, I've shown the Empire State Building here for scale. So these new collapse pits are more than 1,600 feet deep, and I looked it up just this morning. The Empire State Building is only 1,400 and some odd feet high, so we could hide the Empire State Building down inside this newly formed collapse crater at the summit. A dramatically large place. Okay. What's going on? So while all this is happening at the summit of the volcano, meanwhile, 25 miles away, our attention is really split. This is where the action is happening in terms of lava flows. Into July and August, June, July, and into early August, we were continuing to produce these dramatic lava fountains at Fischer VIII and an enormous river of lava heading towards the ocean. Here are some photographs from the air. I had not seen a river of lava this large and this wide since the 1984 eruption of Mauna Loa, which is known for its extremely large and vigorous eruptions. In fact, this was the largest rate of lava production at Kīlauea ever seen in historic times. But it was a very important scientific question to answer: how much lava is coming out? This was partly to help us understand what was coming, because we knew how much volume we had to drain, and if we knew how much we'd already erupted, it might put some bounds on how long the eruption was going to go on. It's a surprisingly difficult task to measure how much lava is coming out of the volcano at once. You can't go out there and probe the depth of the river with a stick. But what you can do is measure the velocity of the lava in the channel. You can measure the width of the channel, and then you can make some estimates of the depth of the channel to come up with some estimates of the discharge rate. However, during the summer eruption last year, we were able to use UAVs, or unmanned aerial vehicles, to do this very carefully. So here's a picture of one of the hexacopters that we used last summer to fly over the lava channel itself in a place where a helicopter would not want to hover, and make very careful maps of the surface moving along the channel. And from this map, we could run it through a computer program to measure point velocities very carefully, and then combine that with some flow models to come up with rates of motion in the channel, and estimate some depths to come up with discharge rates. And we were getting numbers of 130 to 500 or so cubic meters per second, which doesn't mean too much. A cubic meter per second, that's about a pickup truck load a second of lava going by. It was a very, very fast rate. And velocities up above 20 miles an hour in the central part of the channel, certainly faster than you can run. So these very intense lava rivers were feeding lava flows all the way to the ocean. And by June 3rd, lava had reached the town of Kapoho and this beautiful place known as Kapoho Bay. Those of you who've been there before the eruption, you may remember a very popular place for snorkeling and tide pools, a very beloved place to Hawaii residents. Unfortunately, by the time this lava flow was over, it had filled in that bay completely and taken more than 400 homes. It was a very sad thing to watch from the air. This is an animated map showing the progression of lava flows through the eruption. It'll show you the sequence of the growth of the lava as the early fissure vents open, producing separate lava flows, and then activity settling down at Fischer VIII and producing a very large river to the northeast, a hard right to the east where it entered the ocean, filling in Kapoho Bay, extending the coastline out a half a mile, adding 875 acres to the island of Hawaii. There have been some submarine traverses by remotely operated vehicle which are trying to determine the extent of lava flows underwater, and that's a fascinating science story in and of itself. Eventually covering almost 14 square miles and destroying and covering more than 700 dwellings. So lava was active at the surface, feeding these lava flows until about September 5th. Activity really tailed off on August 4th. That was the last collapse event at the summit. Lava was still bubbling about inside Fischer VIII, shown in this photograph, until September 5th, and then things stopped for good. This eruption was really unprecedented in the historic time at Kīlauea. It was the largest collapse event at the summit. Others had been seen before, but this was the largest in terms of volume. 850 million cubic meters of collapse, 62 collapse events, more than 60,000 earthquakes recorded at the summit of the volcano. In the Lower East Rift Zone, where the lava eruption occurred, it was the most voluminous event in the last 200 years. Again, more than 850 million cubic meters were erupted, and I did this math this morning. That's enough lava to bury the entire island of Manhattan in 50 feet of lava. Notice the similarity in numbers. We had about the same amount of lava come out at the eruption site related to the collapse event and the summit, showing this remarkable connection between the two events. As I said earlier, this was the highest sustained discharge rate of lava from the summit from Kilauea in any eruption in recorded time, and also the highest sulfur dioxide emission rates ever recorded at the volcano. So one outstanding science question that we're working on now is, why was this so large? What were the controlling factors? As I have mentioned, more than 700 structures were destroyed. About 3,000 people were displaced from their homes. As you compare this kind of a disaster to something like Hurricane Sandy or the wildfires in California, of course the numbers are much smaller, but for the Big Island, for Hawaii Island, this was really a dramatic and impactful large event. As I mentioned, the air quality had been degraded for much of the summer due to this very enormous gas pollution event ongoing. And I think in terms of the psychology of Hawaii Island residents, the length of the eruption, the protracted nature of the eruption, the uncertainty about how long it was going to continue and how big it was going to get, that had quite a toll on people's emotional state, including our own, I would imagine, to say. I mean, even the scientists, as excited as we were to study this natural event, it was very difficult to watch the scale of loss and be out there every day seeing that. So there was a tremendous mental health impact on Hawaii Island residents as well. And one of the things that was really interesting was when FEMA arrived early in the event to begin to handle disaster assistance, this was the first volcanic eruption they'd really responded to since 1980 and the Mount St. Helens eruption. So nobody in FEMA today remembers Mount St. Helens. And for them, it's not a hurricane event that's done and over. It's not a flood that comes and goes and you kind of are cleaning up. It was a protracted 3-month ongoing event. And one of the things they weren't really ready to deal with was people displaced for that length of time. People not only displaced by lava flows, but people displaced by bad air quality. So FEMA had to work with us to come up with some new approaches to how to handle displaced populations in this kind of natural event. Here's an interesting before and after photograph of the Leilani Estate subdivision showing some of the extent of homes that were covered by lava. People always ask, what happens to the land there and the people who own that land? Well, you still own it. It's still your property. Now you just have 100 or 150 feet of lava on top of your property. We don't know what folks are going to do there and what the county is going to do. This is an interesting public policy question right now. Are they going to allow people back to rebuild? Are they going to try to buy them out and condemn the property and turn it into a park? This is an area of the volcano that's likely to erupt again, and so there are some interesting questions there about proper use of public dollars. In terms of impacts to the infrastructure of the Big Island, they were severe. We lost the geothermal power plant in that region, went offline because several of the geothermal wells were covered, and out of precaution, they shut the whole thing down. That plant had provided almost a quarter of the electricity for Hawaii Island. Fortunately, it was not overrun completely by lava, and they hope to be back online by the end of the year. We lost 58 miles of roads to these lava flows, 900 utility poles, a cell tower, a major electrical substation, the only boat ramp, harbor on that whole coastline was covered, and the national park was closed for a long time and had a lot of damage to the structures from the earthquake activity related to the summit collapsing. Economic impact was severe for the state of Hawaii, many hundreds of millions. I've heard as high as $800 million. Still not a billion-dollar disaster, but for Hawaii Island, this is a very big disaster. Lost tourism revenues, direct losses to agricultural fields that were covered, including, sadly, 80% of the papaya crop. Papayas are very expensive on the Big Island right now. The national park had been a big tourist draw, and so the closure lost dollars for many, many in the tourist industry for much of the summer, and it still really hasn't recovered. So challenges for us scientifically as the organization that really responds to these kinds of events. First of all, we were not used to dealing with ash hazards in Hawaii. We were used to dealing with lava flows. The fact that there were explosive events ongoing really caused us to think about new ways of communicating to people in Hawaii Island about preparing for ashfall. That was a new hazard for people to think about, so we had to adjust our message. In many ways, this was as if we were managing three crises at once. There was the collapsing at the summit of the volcano, there was the torrent of lava pouring out of the ground 25 miles away, and there was also the loss of our building. We had to establish a new observatory in Hilo in the middle of all of this. So it was extremely challenging for us in terms of personnel attribution and management across these crises. When FEMA showed up and an incident command system was put in place, we were suddenly in the middle of dealing with every federal agency known to humankind. The EPA was on scene, the CDC was on scene, the Army Corps of Engineers, the Department of Defense Mass Warfare Response Team. So we became in the middle of this nexus of the federal bureaucracy in a way we'd never quite experienced before. A lot of lessons learned from that experience, which in the beginning was extremely confusing and challenging, but through time we finally got the hang of it. And indeed, now I see how these things are supposed to run and the value of bringing in all that expertise from other agencies. And my final point here, again, is about the big challenge in communicating the uncertainty. What is the volcano going to do? The biggest question people wanted to know, how long am I going to have to deal with this? Should I leave? Am I safe? And as a scientist, when you are focused on studying the process, to be able to turn that information around and give people actionable help, guidance, is challenging. It's a new way of learning how to translate your insights. So looking ahead on Hawaii Island, we're in an interesting time right now in the post-eruption pause. The volcano is quiet. We have a window of opportunity to influence land use planning so that hopefully there will not be such rebuilding in an area of such vulnerability. We can now spend some time on public awareness of ash hazards, which are likely to recur, and also the drama of lava impacting those houses so quickly really taught people how fast lava can move and how people who live in the lava hazard zones need to be ready to move quickly, maybe within a day. Also, for the emergency response authorities, the eruption highlighted many, many vulnerabilities, like our building being on the edge of the collapsed caldera. We need not to do that again. Many of the subdivisions that were impacted had one road in and so one road out. Once that first road was covered, they were stuck. So in terms of subdivision planning now going forward, that has to be considered. And again, the interagency coordination piece, you need to do that ahead of time. They always say, in the middle of a crisis, this is not the time to be exchanging business cards. So we at the Volcano Observatory need to spend time now dealing with all those other agencies and getting ready for the next big eruption, which could be Kīlauea, or it could be the neighboring volcano, Mauna Loa, the big sister, which is 14,000 feet high and tends to produce these very fast and large lava flows that can move down very quickly to populated areas. So even though Mauna Loa is not active right now, it's showing signs of reawakening, and we're still busy planning for what may happen at the Mauna Loa eruption. I want to turn now, Jason, can we turn on that YouTube video? This is about a 3-minute video, and we don't have to see all of it, but it's a lovely piece that demonstrates some of the footage taken by these unmanned vehicles last summer during the event. This was the first time in a United States volcanic eruption that unmanned aerial vehicles were used, both for situational awareness, to track the lava flows, but also to obtain imagery and collect gas measurements, or make gas measurements in places where humans were unable to go. So these early scenes are flights over the collapsed crater, both as it was developing and then after it developed. From these images, scientists were able to stitch them together in the computer using software to create these very detailed topographic maps of the new landscape. There's still a lot of steam coming out of the summit, a small amount of gas, maybe 30 to 50 tons per day compared to the 50,000 tons we were measuring during the eruption. The ability of the UAV to hover over the active lava and take vertical pictures in a stable platform, something you can't really do easily from a helicopter because of the heat and the gas, was just phenomenal. We had crews running UAVs 24/7. And the nighttime footage is also very spectacular. There was a dramatic story where the emergency response authorities used the UAV at night to help rescue someone who inexplicably was still in the residential area when this river of lava was coming down the road, and he was lost. And you see the lights of the emergency vehicles on the road. He couldn't know which way to go, and they used the drone to guide him to safety. For those lucky enough to fly over the lavas or adjacent to them during the eruption, they are really a thing of beauty. In this image, that lava river is probably a quarter or a third of a mile across. These are some downed trees that didn't burn completely as the lava barreled through the forest. And that, if you can tell, that river of lava is actually perched. It's got levees containing it, and so you would walk up the sloping surface to get to the river of lava, where geologists would take samples from time to track the changing chemistry. Using the UAVs and our helicopter overflights, we would make maps every day of where the lava flow had advanced. That's enough, Jason, thanks. So in closing, I just want to say that in honor of the founder of the Volcano Observatory, a man named Thomas Jagger, Harvard and MIT geoscientist, who in 1912 founded HVO, he had the vision that long-term observation of volcanoes with instruments and the human eye, long-term study, was really the basis for understanding how they work and how we can better forecast events that are of hazardous impact to civilization. And really, last summer's demonstrated the power of his vision, because we had monitored this volcano and knew how it behaved, because we had instruments monitoring the earthquakes and the ground deformation. We were able to give at least a few days warning to people that something was coming. And so I'd really like to say he had the right idea, and I hope we're continuing to do his vision honor. And the final thing, of course, is that any volcanic eruption response takes many, many people, and the Hawaiian Volcano Observatory has a staff of 30. This event was so big that we brought in staff from our 4 other volcano observatories on the mainland for rotational shifts to help us out, including many volunteers. And I'd like to say that my partner Gail Ferguson was a volunteer and helped us with our aviation support management. So really, hats off to all of my colleagues. And I think with that, I'm going to stop, and hopefully we have time for some questions.
Thank you so much, Tina. That was fabulous. I'm actually choking back tears. It was so beautiful. I have a couple of questions. Was there a loss of human life during I heard that there was no recorded loss of life during the eruptions. Was there anything, possibly in the aftermath, in hospitals or what have you? So that question, or is there any kind of estimate as to non-human animal loss during this?
Oh, thanks for that question. So there was no direct loss of life that we are aware of. Of course, how you define a direct loss of life gets to be a little challenging. There were people evacuated to centers, Red Cross shelters, for 3 months. And the conditions were difficult, and that was very hard on people. There was sadly a suicide in one of the shelters, so whether that's a direct impact or not, I'll leave that to you. Many people left the island not to return. There were a few serious injuries, mostly from people who were too close to the action. Even though civil defense tried to keep people away, there was no perimeter manned by police all the time. And so folks did get in to see. It was obviously something folks wanted to see up close, and there were a few injuries in that regard. I have heard of other health impacts for sure, and I mentioned the mental health impacts during the event and lingering now, but I suspect there were secondary physical illnesses related to that long dislocation. And then animals. Well, I don't know of animals directly killed, but I'm certain there were, because these lavas were moving through the forest. Areas of ground were surrounded. I'm sure that some animals were trapped and could not escape. But the good news is that over the course of the 3 months, there were people mobilized and spent a lot of volunteer dollars and hours to helicopter into those trapped areas and bring animals out. I kid you not, we saw cows being slung out by helicopter at some point, and many, many cats and dogs, and chickens rescued. And many are up for adoption, if you're interested in it.
In 2016, I stayed in a B&B in Orchid Lands, not in Lilani Estates. And I was interested when I drove to the cottage that we rented that so many of the structures we saw along these roads were a few cinder blocks and some corrugated plastic. And they obviously were really low-budget operations. So I did a little Googling and discovered that this is one of the cheapest places, one of the few affordable places on the Big Island to buy land and build a house. Yeah. Did this remind anybody in government about land use policy in such a way as to change that set of values for the future?
Yeah. Well, that's the million-dollar question right now. You're absolutely right. There was a very mixed housing stock in that area, some very simple structures and some very nice homes. That Puna portion of the Big Island, the Lower East Rift Zone, is currently still the cheapest place to buy land and build homes in the whole state. Affordable housing is a big deal over there. So that's one reason these big subdivisions developed. And now the county is facing that very question. Do they want to change the zoning? Do they want to keep people from building in the highest hazard zone? It's a challenging question. It costs money to buy people out. Many people want to take the risk themselves. So it really is a tricky question. So the county and the state are working together on this right now, but they've not come to any decision. That it's obviously a really big topic of debate right now. And it's not just that part of the island. There are other areas on Hawaii Island that are also in hazard zone 1, as we call it, which is the highest lava hazard zone, where subdivisions are growing quite rapidly. So whatever decision they make there has implications for other subdivisions. So it's a pretty big question. And our role in that discussion is to continue to remind them of the long-term hazard assessment, the long-term behavior of the volcano, so that they can make at least an informed decision. I might add that for many, many families, certainly of Hawaiian descent, living on the active volcano and having the volcano take the property from time to time is just something they expect and live with and accept.
I visited some years ago, and when we were on the ground, the rocks, when we picked them up, were so very light. And I was just wondering, when the rocks that were being thrown out, were they that light or are they heavy?
Well, two places where rocks were being thrown out. At the summit area where the ash explosions were occurring, those rocks were very dense. They would kill you if they hit you. I mean, really heavy, heavy rocks, because they were basically bringing up lava flows from deep within the volcano. down at the eruption site where lava was pouring out of the ground, those bombs going up into the air, some of those were also very heavy and dense, especially the early ones that were cooler and more viscous. But as time went on and the lava fountains were higher, some of the material that came out was very much like pumice, very lightweight. And so that could, a piece of 50% piece size could conk you on the head and it wouldn't hurt. So everything, the whole range of densities.
How long does it take the land generally to recover?
Yeah.
I'm thinking of Mount Etna in Sicily, where there are vineyards growing around the volcano now because the soil is so rich. What's the time frame for something like that?
Right. Well, it depends on which part of the volcano you're on. On this side of the volcano, where we get hundreds of inches of rain every year, lava will repopulate with ferns and small bushes very quickly. In fact, there are small ferns already sprouting on parts of the lava flow that have cooled from last summer. In, I would imagine, 50 years, there'll be trees the size of this room on that lava flow. If you're on the dry side of the island, the Kona side, for those of you who've been there are lava flows that are 3,000, 4,000, 5,000 years old that have barely any grass on them. So it really depends on the precipitation amounts.
Hi. You spoke a bit about changes that occurred on the surface because of earthquakes, and I'm just wondering if you or your team noticed any changes below the surface in the magmatic plumbing system, like
Yes.
changes in flow direction or dikes opening up, or...
Thank you. So what was going on subsurface? Well, a lot, and I think the staff will be looking at the data for a long time to figure it out in detail. But several things we know happened. First of all, that summit magma reservoir that drained so dramatically really didn't completely empty, but is almost emptied of magma. And we know that because the gas numbers went way down, so there's not much magma there still degassing. Also, the summit of the volcano collapsed so much because of all of that change in volume. We are now beginning to see the first signs of rebound. It's just starting to turn around and maybe start to inflate again, which likely means that magma's coming back into that summit chamber. So we'll be watching that closely with a number of different techniques because we want to be able to give warning before it comes to the surface. But the other interesting answer to your question is that during the eruption, every time one of these big collapse events happened, within a few tens of minutes to a couple of hours, we saw a surge in lava output 25 miles away. So this proved what we already knew, and that is that the summit is connected to that rift zone vent. But by looking at the speed of transmission and the scale of the change, we're going to begin to say something about the size of that underground conduit. So those are two big things that happened. This earthquake on May 4th, the magnitude 6.9, that opened up, that moved the south flank so much, it opened up a lot of room in the rift zone. We know that from the motion of the GPS instruments at the surface. We think because of that, it's likely that there won't be an eruption along that rift zone for quite some time now because there's a lot of room to fill. The volcanoes relax and can take magma without an eruption. So those are some of the things. Yeah.
I'm curious about communicating to the audience of teachers and children in schools there. And first of all, was there disruption of school in that neighborhood? And then, on a sort of more medium term, are teachers involved with the USGS in sort of learning how to teach this? Because it is such a compelling issue to the local community and the children, and it's such a center and a way to sort of get the message out to families.
Yes, you're absolutely right. Well, fortunately, or not, well, I think fortunately, this eruption happened in the summer, and so schools were mostly out of session, so classes were not interrupted. There was one Hawaiian charter school on the coast that was destroyed, and so they're looking for a new home. I'm absolutely certain that the event of last summer, will be worked into a curriculum for many, many of the school kids on the island. The USGS co-funds a position at the University of Hawaii in Hilo, where a man goes to the schools and does discussions about volcanoes throughout the school year. So there'll be a lot of discussion about this, I'm certain. And we, the scientists at HVO, occasionally do lectures in the school system. But I think the teachers look at this as a very rich resource to teach a lot of things. Science, public policy, Hawaiian history, absolutely.
Yeah, I'm amazed by the amount of data that you were able to accumulate, but I guess it asks a lot of questions. One of the things is, Was the initiating event a earthquake that dislodged a plug or a weak bulkhead or something like that? Or was there some type of pressure shift that actually started the whole event that caused the drainage of the caldera and the flushing into the...
Yes, so what came first? I think the consensus idea now is that perhaps there was a surge of magma supply from the deeper source. One thing we really don't have a good handle on is at what rate does magma get fed from the deep mantle source? If there was a sudden surge in magma supply, that may have driven the overpressurization of the volcano in March and April, when the lava lake was high and Pu'u'o was expanding. And at some point, I think it did reach a pressure point that it broke through an obstruction that was just to the east of Pu'u'o, and that's what started the magma moving down the rift zone further. And at that time, the whole system started draining. So we're still not quite sure what caused that overpressurization. That's the real key. But then the earthquake had an effect in that it opened up things and allowed it to flow even better.
Will you have to move your volcano observatory?
Will I have to move the volcano observatory? We did have to move the volcano observatory. We moved to the town of Hilo, which was in a safe
will
area.
you have to move it again?
Has he been reading the news? We are looking for a permanent home, and so we will have to move again. Yes, once we build a new home. But we won't move far. Thank you.
You mentioned the fog and the poor air quality during the eruption. What is the air quality like on the island today?
The air is perfect. It's beautiful now. With only less than 100 tons a day coming out of the whole volcano, it's gorgeous clear. People are seeing the coastline on the west side of the island for the first time in 30 years. So it's great, which does not mean you won't smell sulfur. There are times, especially when it rains, that hydrogen sulfide is coming out and will waft over inhabited areas, so we get phone calls. But really, the air quality right now is spectacular. Come visit.
Which is a related question, because I am going to visit in May, so I'm wondering what the current state of tourism is and how close to the volcano can you currently get?
So the park is open, and you can walk up almost to the edge of that big new crater. And I know that they're actively trying to open up more trails to get you closer, but there's some lovely vistas, so it's definitely worth a visit. Some of the other park trails are still closed because of rockfall danger, but there's plenty to see. And then down at the Lower East Rift Zone eruption site, you're not allowed to drive into the subdivisions. Those are all private roads. But there are some places you can drive across the lava flows. The county has already bulldozed a road to the old boat harbor, where there's a new black sand beach, which is very dramatic to see. So there's plenty to see to give you a sense of the scale of impact. If you can afford it, a helicopter flight over the whole eruption site is really spectacular. Then you really get a sense of the extent of the destruction.
It's great that you were able to predict the onset of the danger for people by a couple of days. Were you able to predict the end of the event?
The other holy grail. Yeah, volcanologists say we always are trying to forecast the onset and then, of course, answer the question, how long? So, not really. What we did see in retrospect, and we had started talking about it, I remember, in about third week of July, third week of July, is that the rate of production at the vent seemed to be down, or it was chugging kind of on and off a little more, and then the collapse events, they were getting to be a longer period of repose. So things were changing by late July, and that was a hint that something was going to change, but we couldn't have forecast the last one on August 5th, no. And even then, when things stopped on August 4th, of course, everybody wants to know, is it over? Is that it? And we couldn't say with certainty, because in 1955, an eruption in a very similar type and place had shut off for a couple of weeks and then started up again. So then we had the difficult message of, hang tight, everybody, it's not safe, not all clear yet, we need to stay vigilant. And so after about 30 days, we relaxed a little bit, and then 3 months later, it seemed that the eruption was really over. But I will say that in that region, where the dike was at the surface and cracks were forming, there's still a tremendous amount of heat coming out of the ground. Some homeowners who survived the lava flows are now struggling because there's hot steam pervading the ground and making their homes uninhabitable. That's likely to continue for years. So this is another challenge for FEMA. They've never had to deal with this before.
Yeah, there were two significant, if I remember, rain events in Hawaii, one in April and a hurricane, I think, in August. Did that mitigate or do anything to the lava flows?
Certainly didn't slow the lava down or affect the vigor of the eruption or the collapses, but what heavy rain events on hot lava flows do is create a whiteout condition, basically steamy fog, steamy sulfurous fog, which is very unpleasant and can be very disorienting. In fact, was it February of 2018, a guide was leading some clients to the south coast of Kīlauea where there were some still hot lavas, and one of these rain events occurred, in fact, maybe the one you're mentioning, and a whiteout occurred, and he succumbed to the hot steam inhalation. So they can be dangerous, and we're still warning people about that because these lava flows are still quite hot. Yes, and we did have a heavy rain event, Hurricane Lane, in late August, but other than make life miserable for East Hawaii, it didn't affect the lavas. Yeah. Thank you for the good questions, and thanks again.